Hey everyone. All right, I didn't realize that I had a meeting today, so I'm going to just walk you through the review sheet in case you guys ended up having any questions. I feel bad that I wasn't in class, so I'm just going to walk through these real quick. Okay, so you're simplifying 24, so I'm going to break it down to the square root of 4 and the square root of 6 because the square root of 4 is 2. So therefore, this will equal 2 radical 6. I can't break down 6 anymore because it's not a perfect square and it's not divisible by any perfect squares. For number 2, you want to remember that I can break this down to the square root of 16 divided by the square root of 121, and therefore my answer is going to be 4 over 11. Right? For number 3, the square root of 125, it's not a perfect square, but I do know that it is the same as 25 times 5. Now, since I'm breaking down radical 125, I break it down to radical 25 times radical 5. Then I know the square root of 25 is 5. I multiply these two 5s together to get a final answer of 25 radical 5. Number 4, the square root of 48. I know that 48 is divisible by 16. That's the largest perfect square. So I'm thinking of it as radical 16 times radical 3, and the square root of 16 is 4. So it breaks down to 4 radical 3. It is here's a Regents style question. It's saying if in simplest form it's a radical b, what's the value of a? So technically a equals 4 here. I don't think that shows up on the answer key, but that would be what the answer is. All right, number 5, I'm breaking down radical 24 to radical 4 times radical 6. The square root of 4 is 2. This 2 with this 3 gives me 6 radical 6. Over here, I'm adding. So when I add, I need to have like terms. So I'm going to break both of these down. 50, I see 25 because I know the square root of 25 times 2. Radical 25, radical 2. The square root of 25 is just plain old 5 with that radical 2. 72, when I divide 72 by 2, it reminds me that the largest perfect square is 36. So I have radical 36 times radical 2, and the square root of 36 is 6. And I leave that 2 under the radical, and then you're combining these. Because they're like radicals, you add these coefficients, so you're going to get 11 radical 2. That's my final answer. Number 7, sum means you're adding. I'm going to break 45, radical 45 down to radical 9 times radical 5, and the square root of 9 is 3. So I have 3 radical 5 and radical 5 being added, and 3 plus the 1 that would be there is 4 radical 5. This one, I'm going to break, again, I'm adding. They need to be like radicals, so I'm going to rewrite 27 as radical 9 times radical 3, and the square root of 9 is 3. So that radical 27 breaks down to 3 radical 3. I'm going to bring down 2 radical 3. I'm adding them. Since they're like radicals, I add the coefficients. 2 plus 3 is 5. And then you leave that like radical alone. Number 9, same idea. I'm breaking them down. Radical 48, again, that repeated. I know radical 48 is radical 16 times radical 3. The square root of 16 is 4 radical 3, and I'm going to bring down this minus 3 radical 3. 4 minus 3 is 1, and I leave the radical 3 alone, and 1 radical 3 is the same as radical 3. They want the product, so I'm multiplying. So now this is when things can get a little bit, you can kind of make your choices. If you happen to notice the square root of 16 is 4, so if I had radical 5 times 4, that just equals 4 radical 5. Okay, because the same way if I had x times 4, it would equal 4x. It's that same concept, except instead of it being an x, it's that radical 5. Radical 5 times 4, leave the 4 outside, and that 5 stays inside. Okay, all right, next one. Over here, I am multiplying. Now, you have a choice as to whether or not you want to simplify these first. I'm going to choose to do that because I'm just going to end up making these numbers so big that I'd rather just break them down right now, although you do have a calculator. So you could and it really is up to you. I have 18 times 27 under the radical, so I'm going to get radical 486, right? So that means I would get 2 times 3 is 6, right? And then 18 times 27 was 486. And then if you recall, some of the kids were asking me to do that whole like 486 divided by x if you wanted to look at that list of numbers. And these are like, so 1 times 46, 2 times 2, 43. And I'm looking for a perfect square. And look at that. I see 81 there. So 6 and 81 works. So I'm going to rewrite this as, here's my 6. I know that radical 81 times radical 6 multiplies to give me radical 684, and the square root of 81 is 9, and 6 times 9 is 54 radical 6. Again, I did outsides by outsides. 2 times 3 is 6. 18 times 27 is 486, and then I tried to figure out the largest perfect square that 46 is divisible by, which ended up being 81. Radical 81, radical 6. Break down radical 81 to 9, then outside numbers by outside numbers, 6 times 9 is 54, and then bring down your radical 6, and you are done. Unless you want to break these down from the beginning, it's up to you. Over here, I know 48 divided by 3 is just 16, so you can do the math under that radical and just get 16, and the square root of 16 is 4. This one, when I'm dividing, I do outside numbers by outside numbers. 8 divided by 2 is 4. And 64 divided by 16, that's an inside number, that's going to give you 4 under the radical. Then I got to simplify this. The square root of 4 is 2, so I really have 4 times 2 equals 8. And again, I did try to show you guys that you could check your work. If you wanted to check this, use parentheses. 8 second radical 64, come out of your radical, close your parentheses, divided by, open your parentheses, 2 second absolute value 16, close it. Oh, sorry, wait, let me delete that, and then come out and close it, and then hit enter, and I get 8. I can kind of check it that way. It worked out nicely because it's just straight up the number 8. If you had 8 radical 3, it's going to give you a decimal. You wouldn't be able to necessarily check it unless you typed 8 radical 3 and made sure it was the same decimal. I can try to show you what I mean for a question that happens. All right, let's look at this one. Maybe it'll happen here. 20 divided by 4 is 5. I can't do 8 divided by 3. It doesn't happen nicely. So that means I got radical 8 at the top and radical 3 at the bottom. We don't, technically I'm done, but we need to rationalize. We don't leave radicals in the denominator. We're going to multiply by that quote unquote 1, but the version of 1 is going to be radical 3 over radical 3. Multiply across, I'm going to get 5 radical 24 divided by radical 3 times radical 3 would give you radical 9, and the square root of 9 is just plain old 3. Now I'm not done anymore because I can break 24 down. I'm going to bring it over here. So 5 radical 24 over 3 is going to become 5 times radical 24 is going to be radical 4 times radical 6. Radical 4 is 2. 5 times 2 is 10. Radical 6 over 3, and that is simplest form. Okay. And let me explain to you what I mean. So on the calculator, let's say you wanted to check your work. Again, I'm going to do parentheses 20 second square root of 8, come out, close my parentheses, divided by, open it up, 4 second radical 3, come out of your radical, close it up, and I get this decimal. Now if I type my answer, this is what I was trying to say before because it's not necessarily a nice number. So 10 second radical 6, I'm going to come out, divided by 3, enter, and I get the same decimal. So I don't know if it's in simplest radical form, but I do know I still have an equivalent answer. So it's a good answer. Hopefully it's simplified, which it is in this case. Okay. All right. Over here, I like this. I can simplify the 2/6 down to 1/3 radical 2. I wish I were done, but because I have to rationalize, I don't want to keep that radical 2 in the denominator. So I'm going to multiply by radical 2 over radical 2. When you multiply, go across. 1 times radical 2 is radical 2. And then 3 radical 2 times radical 2 is going to be 3 times 2, which is going to give me 6 in the denominator. And then you just have radical 2 over 6, which is, there's nothing wrong with that. Your radical's not in your denominator. You're done. You can't simplify it down because you have an inside number and an outside number. For number 16, you are adding together radicals, so you need like radicals. My brain I'm seeing 32 here, so I'm going to break 72 down to radical 36 times radical 2, which is, this becomes 6. So that just became 6 radical 2. Don't lose this 2 here, and then radical 8 is radical 4 times radical 2. Square root of 4 is 2. Times this 2 is then going to give me a positive 4 radical 2. This is my 4 radical 2. And then 32, don't lose the fact that this is a minus sign. And then 32 is radical 16 times radical 2, and the square root of 16 is 4. So this just became 4 radical 2. I can see that 4 radical 2 minus 4 radical 2 cancels, and therefore my final answer is 6 radical 2. All right. Here are some of the questions I got period 1. I'm going to do my order of operations. I'm going to add the top of this first. So I'm going to actually go up. I'm going to start with 20 because I know 20 is divisible by 4 and 5. So square root of 4 times square root of 5, and the square root of 4 is 2. So this just became 2 radical 5. That's a nice hint to me because then I say, I wonder if 80 is divisible by 5. And when I do 80 divided by 5, I get that perfect square of 16. I used 5 because this one had a radical 5. So now I know 80 divided by 5 is 16. Don't lose the 5 out in front. The square root of 16 is 4. Times that 5 out in front, and this gives me 20 radical 5 with the plus sign. So then 20 radical 5 plus 2 radical 5 is 22 radical 5 over 5. And I am done. These don't divide nicely. You could make it a decimal if you want, but they don't divide nicely, so you can leave it. And my radical is on top, not in the denominator, so it's fine. Number 18, again, I'm going to divide here and then subtract, order of operations. I can do 15 divided by 5 is 3. That's outsides by outsides. Here's insides by insides. I can do radical 24 divided by radical 12 is 2, but don't forget that 2 is under a radical. And then I have minus 2 radical 18. Because I'm subtracting, I need like radicals. So I'm going to do radical 9 times radical 2. Square root of 9 is 3. This 3 with this 2 becomes 6 radical 2. Don't lose that minus sign. And then bring down 3 radical 2 minus 6 radical 2 is equal to 3 minus 6 is negative 3 radical 2. Right? Over here, I want to add before I divide. I cannot add these. A brain shift. If I'm multiplying, I could do insides by insides, but I have 2 radicals. I'm adding them. I need to have like radicals. So I see 9 and 5 here. So I'm going to see square root of 9 times square root of 5. So this just became 3 radical 5. This is 125. So I see 25 times radical 5, which is 5 radical 5. All over radical 20, which I could break down 20. I'm going to wait a second though. So now I'm going to have 8 radical 5 divided by, I guess I should do this. So radical 20 is radical 4 times radical 5. The square root of 4 is 2. So that means radical 20 is 2 radical 5. 8 divided by 2 is 4. And radical 5 divided by itself is 1. Anything divided by itself is 1. And then your final answer is 4. Okay. You could have also seen radical 5 divided by radical 5 as square root of 1, and the square root of 1 is 1 as well. And then 4 times 1 is 4. This is order of operations. You're going to break this down. Radical 48 is radical 16 times radical 3, which square root of 16 is 4. 4 times 3 is 12 radical 3 minus 75 is radical 25 times radical 3, which is going to give you 5 radical 3. That means in that parenthesis, 12 radical 3 minus 5 radical 3 is 7 radical 3. This outside, I'm going to do radical 9 times radical 3, and then the square root of 9 is 3 radical 3, but 3 times 1/2, so 1/2 of 3 is 1.5 radical 3. Don't lose this minus sign, which goes here. And then 1.5 radical 3 minus 7 radical 3 is negative 5.5 radical 3. Okay. All right. Number 21 is just getting fancy. They're telling you to find the perimeter of a rectangle who has a length of 10 plus radical 24 and a width of 4 plus 2 radical 6. So really for that one, you have, remember for a rectangle, you have 2 lengths and 2 widths. So I'm going to double this length, and I'm going to double the width to get that perimeter. Distribute. 2 times 10 is 20. They're both outside numbers. 2 times radical 20 is just 2 radical 24, right? Distribute. 2 times 4 is 8. And 2 times 2 radical 6 is going to be positive 4 radical 6. I'm going to, you can combine the 20 and the 8 to give you 28 plus 2 radical 24. Plus 4 radical 6, and I'm going to break this radical 24 into radical 4 times radical 6. Square root of 4 is 2. Don't lose this 2 and this 2, which will give you 4 radical 6 plus that other 4 radical 6 plus 28, which means your final answer is going to be 28 plus 8 radical 6. Remember, when you're adding, you have to have like radicals, and you only add those coefficients. Okay. For this one, they're asking which one is rational. So I want perfect squares. If you notice, these two are going to multiply to give you square root of 36, because insides by insides, I'm allowed to multiply. That will equal positive 6. If someone's opening the door. I'm sorry, Miss Peltier, I'm just making a quick video. I'm sorry. I'm in the middle of the video. I'll be 2 seconds. Hey, you guys, I'm almost done. So 5 radical 5, that's a non-perfect square, so that's irrational. Okay, this 1 radical 2 plus 1 radical 2 is going to equal 2 radical 2. That's irrational because I have this non-perfect square component, and both of these are non-perfect squares, so those are irrational. So this is the only one that's going to turn up rational, right? The product of 2 irrational numbers is always irrational. That's false information. And the example we came up with in class is something like radical 2 times radical 2 will equal radical 4, which is equal to just 2. This is irrational times irrational is going to be rational. So that's why this is a false statement. Over here, the product of the square root of 16 and 4/7 is it rational or irrational? Now, looking at it, I have a rational number times a rational number. So I can say a rational number times so rational numbers times rational numbers will always equal more rational numbers. So therefore, it is rational. Okay. And I'm going to say because, and I'm going to write always. It's always true that rationals times rationals. You could also use your calculator and do this. I know the square root of 16 is 4. 4 times 4 sevenths is just going to equal 16 sevenths, which is a fraction. So that is a rational number. This is an irrational number. And I'm looking for the product, so I'm multiplying an irrational number times a rational number, right? So I'm basically doing the square root of 3 times the square root of 9, which is just 3. And that's going to equal 3 radical 3, which is irrational. And it's irrational because this is a non-perfect square. Okay, so therefore it's irrational. And I think that is everything. All right, I hope this is helpful. I will have extra help tomorrow morning if you need, okay? All right, have a great day, you guys. I hope this helps.